So let's introduce ourselves to the polynomial remainder theorem. And as we'll see, it'll feel a little magical at first, but in future videos we will prove it, and we'll see, well, like many things in mathematics, when you actually think it through, maybe it's not so much magic. So what is the polynomial remainder theorem? Well, it tells us that if we start with some polynomial, f of x, so this right over here is a polynomial, and we divide it, divide by x minus a, then the remainder from that essentially polynomial long division is going to be f of a. It is going to be f of a. F of a. I know this might seem a little bit abstract right now. I'm talking about f of x's and x minus a's. Let's make it a little bit more concrete. So let's say that f of x is equal to, I'm just going to make up let's say a second degree polynomial. This would be true for any polynomial though. So 3x squared minus 4x plus 7. And let's say that a is, I don't know, a is 1. So we're going to divide by x minus 1. So a, in this case, is equal to 1. So let's just do the polynomial long division. And I encourage you to pause the video. And if you're not unfamiliar with polynomial long division, I encourage you to watch that before watching this video, because I will assume you know how to do polynomial long division. So divide 3x squared minus 4x plus 7, divide it by x minus 1. See what you get as your remainder, and see if that remainder really is f of 1. So assuming you've had a go at it, so let's work through it together. So let's divide x minus 1 into 3x squared minus 4x plus 7. All right, a little bit of polynomial long division is never a bad way to start your morning. It's morning for me. I don't know when it is for you. All right, so how many? I always look at the x term here, the highest degree term, and then I'll start with the highest degree term here. So how many times does x go into 3x squared? Well, it goes 3x times. 3x times x is 3x squared. So I'll write 3x over here. I'm writing it in the, I guess you could say, the first degree place. 3x times x is 3x squared. 3x times negative 1 is negative 3x. And now we want to subtract this thing. And this is just the way that you do traditional long division. And so what do we get? Well, 3x squared minus 3x squared, that's just going to be 0. So these just add up to 0. And this negative 4x, this is going to be plus 3x, right? A negative of a negative. Negative 4x plus 3x is going to be negative x. Let me do this in a new color. So it's going to be negative x. And then we can bring down the 7. Complete analogy to how you first learned long division in maybe, I don't know, 3rd or 4th grade. So all I did is I multiplied 3x times this. You get 3x squared minus 3x. And then I subtracted that from 3x squared minus 4x to get this right over here. Or you could say I subtracted it from the whole polynomial, and then I got negative x plus 7. So now, how many times does x minus 1 go into negative x plus 7? Well, x goes into negative x negative 1 times. Negative 1 times. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. But then we're going to want to subtract this thing. And this is going to give us our remainder. So negative x minus negative x, that's the same thing as negative x plus x. So these are just going to add up to 0. And then you have 7. This isn't going to be 7 plus 1. Remember, you have this negative out. So if you distribute the negative, this is going to be a negative 1. 7 minus 1 is 6. So your remainder here is 6. One way to think about it, you could say, well, actually, I'll save that for a future video. This right over here is the remainder. And you know when you got to the remainder, and this is just all a review of polynomial long division, is when you get something that has a lower degree. This is I guess you could call this a 0-degree polynomial. This has a lower degree than what you are actually dividing into, or than the x minus 1, than your divisor. So this is a lower degree, so this is the remainder. You can't take this into this any more times. Now, by the polynomial remainder theorem, if it's true, and I just picked a random example here, this is by no means a proof, but just a kind of a way to make it tangible of what the polynomial remainder theorem is telling us. If the polynomial remainder theorem is true, it's telling us that f of a, in this case 1, f of 1 should be equal to 6. It should be equal to this remainder. Now let's verify that. This is going to be equal to 3 times 1 squared, which is going to be 3, minus 4 times 1, so that's just going to be minus 4, plus 7. 3 minus 4 is negative 1, plus 7 is indeed, we deserve a minor drum roll, is indeed equal to 6. So this is just kind of, at least for this particular case, we're saying, okay, it seems like the polynomial remainder theorem worked. But the utility of it is if someone said, hey, what's the remainder if I were to divide 3x squared minus 4x plus 7 by x minus 1? If all they care about is the remainder, they don't care about the actual quotient, all they care about is the remainder, you can say, hey, look, I can just take that, in this case, a is 1. I can throw that in. I can evaluate f of 1, and I'm going to get 6. I don't have to do all of this business. All I would have to do is this to figure out the remainder of 3x squared, when you take 3x squared minus 4x plus 7 and divide by x minus 1.